Hello Stonites, welcome to LFI Educates. I hope all of you are safe and sound at home. Let us start with the new chapter Forces and Motion, chapter number 9. The topics we will discuss are seeing forces, forces big and small, and weight, the pull of gravity.
What is a force? Can we see force? What does force do? A push, pull, stretch, or turn is considered as force. We cannot see force, but we can feel it. We use force to push a car or any object. We use force to pull the chair or a table. We use force to stretch a rubber band or a bow. And we use force to turn the door handle or cap of the bottle. We use force every day in our lives. Sometimes we use more force while sometimes we use less. Most of the time we do not even know that force is acting on our body, like the force of gravity that is pulling us down. While sometimes we feel the force, for example, if something falls on our body. There are nerves all around the body which can detect pressure and we feel the force. Since we cannot see force, we use the force arrow to show force. The force arrow shows the direction of the force. We label the force arrow to show two things: the object that the force is acting on and the object that is producing force. In this picture, the person is pushing the trolley. The force arrow shows that the person is pushing and the trolley is being pushed. This helps us to understand where force comes from. Force appears when two objects interact with each other. In this case, it is the person and the trolley. Force can make things move. If we want to move a trolley forward, we push it, or if we want to bring it back, we pull it. How do we know how much force is being applied? We can use an instrument called a force meter or a Newton meter. It looks like a weighing scale used to measure the mass of an object. How do we use force meter? Firstly, we have to always check if the reading is at 0 before we start. Then attach the hook of the force meter to the block. Hold the ring at the other end and pull back the block. Then we read the value shown in the scale. When we pull, the spring stretches and moves the indicator, giving us the reading in the scale. The unit to measure force is newtons. It is named after Isaac Newton, who explained how force affects the way things move. We write N instead of Newton. How much is a Newton? If we hold a regular size apple on the palm of our hand, we can feel the force pressing our hand down. This force is approximately 1 Newton. If we hold 5 apples, the force will be 5 Newtons. If we stand on a weighing scale and see the weight, it shows in kgs. So, in order to convert it to newtons, we can multiply it by 10. So, 1 kg equals to 10 newtons. Similarly, 5 kg equals to 50 newtons. You can check how much force you can apply by trying in different positions. Weight, the pull of gravity. We all know that gravity pulls everything back to the center of the earth. If we jump, we fall back and not float in the air. This gravity causes a force that pulls an object downwards. This force is called weight. Just like other forces, weight is measured in newtons. So if we draw a force arrow for weight, it will be pointed towards the center of the earth. So the question arises, if gravity is pulling us down, then why don't we fall through the floor? This is because the floor also gives an upward force. This force is called contact force. This upward force is big enough to balance the force of gravity. But when we sit or stand on something that is not strong enough, we fall down because the upward force was less than that of gravity. Mass and weight. When we weigh ourselves using the weighing machine, we say that my weight is 50 kg. But in science, we say that my mass is 50 kg. The mass is measured in kilograms. It tells us the amount of matter the object is made of. The Earth's gravity pulls each kg with the force of 10 Newton. So if my mass is 50 kg, my weight on Earth is about 500 Newton. You must have noticed that I said my weight on Earth is 500 Newton. This is because the force of gravity on Earth is different than on Moon or any other planets. This is why we float in space, as there is no gravitational force acting on our body, but our mass is still 50 kg of matter.
This is all we have for today. I hope all of you are submitting your assignments on time. Till then, take care and have a good day.